No, it's referring to. That would be.
All right, so what do you think for number 1 here? Find the angle or angles with a sine equal to root 2 over 2. What did you come up with? Colin?
Well, for a start, I had 0.255,
For a start, you had what?
0.255,
Pi over 4, 3 pi over 4. How many agree? The sine ratio is positive when y over r is positive. This all goes back now to sections 4.2 to 4.4. All going to be important again, so if you got a little rusty on that, brush up on it over the weekend. This was the quiz before when we talked yesterday. So it's positive when y is positive. So we're in quadrant 1 or quadrant 2, and given these ratios, if this is root 2, and 2, that is a 45, 45, 90 situation, right? If you multiply by root 2, you get the other side of hypotenuse. So yeah, this is pi over 4, and this is 3 pi over 4. But is that all the angles that have a sine ratio of root 2 over 2? Awesome.
Well, since I didn't say in radians, I just thought about it in degrees.
Sure.
So I got like sine 45 degrees. And you also think anything will make 45 degrees as the reference angle.
So
180 minus 45 is 35.
135, yeah. So you're giving me the same answers here, but in degrees. So pi over 4 radians is the same as 45 degrees, and this is the same as 135 degrees.
And then negative.
No, because in negative, then if it's negative 45 degrees, that would have a negative sine ratio, not a positive sine ratio.
Oh, okay.
So we have to stay in quadrants 1 and 2.
Okay.
Chris? Yes, we need to get all the coterminal angles with these, right? So if I want all the angles that have this sine ratio, I've got to keep cycling back to these 2 locations. And how do we do that? Well, we did that. That goes way back to section 2. Actually, section 1 we did coterminal angles. So we could have, if it's in radians, pi over 4 plus 2 pi k, and 3 pi over 4 plus 2 pi k. What has to be true about k? It's got to be an integer. And that would take care now of all the angles that have a ratio for sine that's equal to root 2 over 2. Of course, we could have done that in degrees. Instead of plus 2 pi k, do 45 and 135 plus 360k, where k is an integer. And you can use whatever variable you want to there. But does that make sense? So do you want to change your answer for number 2? See what you think. Today's Secret Trivia question. Name the artist who sings a song entitled Still Feel Like Your Man. Still Feel Like Your Man. 1 and 87.
I'm ready to hear
Nebs.
41.
Anybody else? Number 6. Nebby. Billy Joel. Incorrect. No.
Joel Billy.
Not Joel Billy. Nobody knows that. It's by John Mayer.
Yeah.
No, we'll come up with another. Well. So what did you get for number 2? Pi? Where is the cosine equal to -1? That only occurs at this location, the quadrantal location as we go around the circle. Maybe you thought of that as -1 comma 0. However, we have an infinite number of ways of getting there, don't we? So if you say pi, you want to add to that plus 2 pi k, where k is an integer. Of course, you could have done that in degrees, 180 plus 360k. How many had that or something equivalent? Okay. How about the third one? The third one. Cotangent. What's the ratio for cotangent? We haven't scratched this. Ratio for cotangent is what, Jake?
X over Y.
X over y. So that would be negative in what quadrants? That would be negative in quadrants 1 and 4?
2 and 4.
2 and 4, yeah. 2 and 4, because there x would be negative, y would be positive here, x would be positive, y would be negative. So we've got both of those locations, and we want cotangent to negative root 3 as our x. This would be positive root 3 over negative 1, and this would be negative root 3 over positive 1. And so what would the missing side be? 2. And that is a special triangle. What's the reference angle? What's the reference angle here, Austin? 30 degrees or pi over 6. I did these in radians, I'll do this in degrees. 30 degrees. So we could do this as two separate things like we did the first one. However, because these are exactly straight across from each other like that on a straight angle, we can do this a little more efficiently. So what could we call that angle? I'm in degrees, so 180 minus 30. 150. So it'd be 150 degrees, and I could add, instead of adding 360 degrees each time, I could add 180 degrees and keep hitting that, right? So add 180, put the degrees after the quantity. So 180k quantity degrees, where k is an integer, and that would take care of both of those locations, wouldn't it? Because they're exactly across from each other in a straight line. You can't always do that. We couldn't do that up here if they didn't have that relationship. But if they do, save yourself a little bit of time. It's not wrong if you write it out with two of them either. Questions there? Yes?
Why did you write it out with,
Why am I writing it out that way?
what about
30 is not one of the angles. 30 is in quadrant 1, not in quadrant 1. I can do negative 30.
Yeah.
I can do negative 30, but the standard is to use the angle within one positive rotation. That's why I chose 150. If you wrote negative 30 plus 180, okay.
About,
great. That would be, yeah, that would work. What about the last one? The sine of the tangent pi over 4. Think there. Talk it over with somebody nearby. Come up with something for that.
Well, the tangent of pi over 4 is the 45-degree angle. So that ratio is 1 over 1. The sine ratio of that 45-degree angle would be 1 over root 2. And I got 1 over root 2. I don't know if that's right or not.
What time are we up to?
7 or 8 minutes.
What do you have? Sine of the tangent of pi over 4. Mr. Cobb.
You want the answer?
Yep.
0.8415.
How many have 0.8415?
Is that 1 over root 2?
Oh, no calculators.
1 over 2 then.
1 over root 2? No.
Is it 1 over 2? I don't know. No, that's not 1 over 2. I don't know. That's what it is. What's it? 57.3 degree angle.
All right. The tangent of pi over 4 is what? 1. What's the sine of 1? My friend. The sine of the tangent of pi over 4. We must consider what's going on here. Careful. Yeah. No. The tangent, no, but you're on the right track. The tangent of pi over 4 is the tangent of an angle, which gives you a ratio. What do we take the sine of? We take the sine of angles, right? Not ratios. This problem is complete and utter poppycock. Nonsense. Hogwash. This makes no sense. You don't take the sine of a ratio. So always keep in mind what you're dealing with. A lot of people just get into the sort of robotic way of going through these problems. Think about what you're doing. The tangent of pi over 4 is a ratio. You can't take the sine of a ratio. Some people say, oh, but it's the sine of 1 radian. No, it's not, because it's, when you take a ratio, there are no units attached to it. It's just a ratio, yeah.
Are we just supposed to use that ratio?
No. No, this makes no sense. Sine of the tangent, no good. Okay?
You got that?
I think what Hunter's getting at is, I said that if there are no units attached, it's, we assume radians. But that only applies if it's an angle, right? You don't have radians for a ratio. That makes no sense. So because you know it's a ratio, it makes no sense to take the sine of that value. No, you can't do that. This makes no sense because in every case, the tangent of pi over 4 is going to be a ratio, and you will never take the sine of a ratio. Yeah. Oh, so that's gone, and you put. Oh, that could happen. Yeah, that could happen. But that's not this problem. Yeah, it's a different problem. Yeah.
I just don't understand. You can put any equation.
Go ahead and pause the video.
Sorry, not every.